If you can hear me, that is great. Okay, well, welcome everybody. Welcome to this webinar about GitHub. This is an introduction to GitHub, but we will also discuss some advanced subjects. Let me move to the... So my name is Clement Valens. I will be moderating this more or less. I will also be presenting something. I will do this together with Matthias, who is sitting not at all next to me, but about 900 kilometers away. Hi, Matthias. How are you?
Hi, Clemens. I'm fine. Thanks. It seems your connection is this time really good. And
well, the weather isn't, but maybe, yeah, strange. There is no correlation, apparently.
Yep. I will be the co-host for today. I'm also one of the engineers and editors at Elektor. And Clemens will start with his part to give you a first insight into GitHub, and then we will continue a little later.
Yes, exactly. Thank you. What is GitHub? Huh? So GitHub is a hub for Git. Git is a so-called versioning system, which means that it keeps track of changes made to the documents that it knows of. So the main purpose of Git and GitHub is to allow groups of people to work together on the same software project, usually. GitHub has evolved and a lot of people put other stuff in it besides software, but basically it's about software. Also, GitHub is actually sort of a professional tool and production quality tool. And so it is very complicated. There's a lot of functions and options that most people never use. At least I never use them. But they make the whole thing a bit complicated. So we did a video on GitHub, and it got quite a really amazing number of views, showing that GitHub people are not really familiar with GitHub, and so we decided to do this webinar. I will start now with the basic things, which is simply how to download something from GitHub. For that, I will launch a recording, which we have here. There we go. So imagine that you did a search on the internet and you ended up on this page. Here you are at GitHub in my repository, and you see a bunch of files which are part of the repository, but the repository is lidar controlled autonomous vehicle, and you are somewhere in a subfolder called source. If you click on a file, the file opens, then you can inspect it. But if you want to download it, for instance, by right-clicking on it and then save as, you will see, as you can see, it will save a web page and not the source code. Here I have an HTML file. I'm not interested in that. Actually, if you want to download this file, you can click the raw button. If you click raw, you get the file in raw mode, and now you can do a right-click save as. Now you have the CPP file, as you can see. You can also go back and do a right-click on raw, and then it will save immediately to the right file. Now you have the real camera module.cpp file. Now this is of course very tedious to do for a repository with a lot of files, so it's much easier to go to the download button. But where is the download button? That's a good question. To find it, you have to go to the root of the repository. So the root of the repository is this bit, lidar controlled autonomous vehicle. It's the part that comes right after the name of the GitHub user. There we go. Okay, here we have the root. Usually there is a description. And still there is no download button. There used to be a download button, but they renamed it. They renamed it to code. And it's the green button here, which is code. If you click on the arrow at the right of code, you will see here a download zip option. So if you click on that one, it will download a zip file. And if you open the zip file, you will see that inside there is everything you see in the GitHub on the GitHub website. Here we are. This is where we were. This is where we were earlier. The only problem with downloading a zip file is that the name main gets postfixed to the name of the repository. So if you want to have the real repository, you have to remove the postfix main from it. In this dialog there is some more stuff. There is also a clone option. And there's open with GitHub Desktop. Matthias will talk about GitHub Desktop, I think. So I will not do that. I will show you how to clone later on. Sometimes in repositories you are not really interested in the source code because you don't know what to do with it, but you are looking for a binary or something. Some repositories have releases. Here on the right there is a releases box, releases tab, and you can see there is one release, and if you click there then you get the releases. So there is only one here, first working version, and you can download the source code from here as well. Let's do that. Now I have the zip file, which is postfixed with 1.0 because it's release 1.0. And as you can see, it's all the same files as before. Now in this case there is no binary. There are no binaries, so the example is not as good as you would like. But for repositories that have binaries, you might want to check the releases tab or box. Go back to the main page. Like I said, I will also tell you how to clone something with the code clone option. For that you must open a command line window, command prompt, temp, and you must of course install the Git command line utility, which you can find on the Git website. I already have it. Now it's very easy. You just type git clone space, and then from this window you take this, you click the copy button, and then right click, paste it into your command line window and press enter. Here it clones the repository. If I look it up, here I have a folder, the zip files, and here's my repository. There we have it. And there we have all the files. So this is how you clone something, and now you have the real repository exactly as it is at GitHub. So basically that is how you do how you download something from GitHub. So as we saw, downloading something from GitHub is not so complicated. It's quite easy once you know where to click. And now let me show you how to upload something to GitHub. Imagine that you want to publish your own project at GitHub. So for that you first have to create an account, of course. Imagine also that you did that. And then you go to your profile, the root of your account, which in my case is here. And then you go to repositories. Here you can add a new repository to it. For that you click on the new button and you enter the name of your repository. My project, for instance. You enter a description. My project to illustrate. I make it a public project because I want anyone on the internet to see this repository. I will not add a README file because I already have one in my repository. I don't care about this, and it's always good to choose a license. There are a lot, there are many. You can look them up after this webinar. I go for, let's say, MIT license, and then create repository. Okay, and now comes the clever bit of GitHub, because you can simply drag and drop your code on the page. So this is my project. As you can see, I already created a README file. I just drop it on there. It uploads everything. And then you click commit changes. Takes a while. And there we are. Here is my repository published at GitHub. So I have a source folder, and there I have a main.c file. It's pretty simple. Okay, let's see. As I said, I have an README file. I created a README file, so that it looks like this. You can edit the README file here. You can change the text. You don't have to create a README file before you upload it. You can make GitHub create one for you. Then you have to edit it yourself, of course, afterwards, once it is created. I think it's easier to prepare one in advance, so you can think about it and don't have to commit 20 changes before you are happy with it. In this README, you can also have images and links to other things, so it's pretty useful to document your project. Okay, so now we have our project. Now imagine that I changed my source file. So go to my source file, edit with Notepad, don't make it too complicated. Notepad++, let's change this to hello Elektor webinar participants. Okay, I save it. So now I have a updated main.c file that I want to update also at GitHub. Again, this is very easy. Here is my file. I go to the place where it is and then simply drop it. And then can change changed welcome message. So there we go. And now my main.c file has been updated. So this is really easy actually, the drag and drop interface at GitHub. Here you can see what I did to the file. The red bit is what was removed, the green bit is what was inserted. And somewhere there should be my comment. Here it is, changed welcome message. Okay, so this is very easy. You can also in the same way add files to your repository and delete files. Let's say that I want to delete this file. Go to file, here you can click delete this file. You have always to commit your changes. Whatever you do to it, you have to commit it. So I commit it and it's gone. Now, if you are not happy with your repository at all, you can also delete your repository. For that, you must go to the root of your repository and then click the settings button here. Not this one, this is about your GitHub project. Your repository is about the way you can change the description. But these settings, and from here you go to options, and then you scroll down all the way down to the danger zone, and there is the option delete this repository, and then you must type this security question answer thing. So you have to be really sure to want to do this project. Then I understand the consequences, delete this repository. And now it's gone again. So this is the easy way to post something on GitHub and to manage your repositories at GitHub without installing any clients or command line tools or whatever. There's one thing though, when you do it this way, your repository at GitHub is a copy of what you have on your disk. When you do it the official way, then GitHub is the main repository and what you have on your disk is a copy. That's sort of the idea. GitHub is a versioning system and it's supposed to keep track of your changes, and if you do your changes locally, then you have to commit them all the time to GitHub. And in this case, the GitHub part is the slave of your repository. You can make it the master by cloning it from GitHub and then start working the normal way, as Matthias will tell us now, I think.
Okay, just before Matthias starts, let me tell you that you can ask questions by typing them in the chat box in the right lower corner of the screen. There's a chat box. Also, this webinar is being recorded and will be posted at our YouTube channel. So if you want to watch it later, then you can. Let me switch back to the presentation. And then Matthias will continue about here. Okay, Matthias, up to you.
Yes, thanks, Clemens. We had a little echo somewhere. Should be gone. Okay. Yeah, as Clemens started to mention, there is a little bit more to GitHub than just the web interface. And what we are going to need to have a look is what is the Git in GitHub. And yeah, Git means from its original meaning, British English, unpleasant person. And Git, or this version control system, was started by Linux towards in 2005. They needed a new source control management system for the Linux kernel, and that is what it's primarily intended for. Git is free and open source, so the basis. It's a distributed version control system. That means even if there is a master, every copy you get has the full history, full version tracking capabilities, and every Git repository you clone runs independent of a network server. We'll come to that later. But you can use a server. So Git itself, the Git software, can act as a server, but Git offers no access control, no user management, no GUI or web interface whatsoever. So security, access control, and user management must be added some way else. So the Git, or this version control system, you can host it yourself. You can, under Linux, just install the Git binary and start it as a daemon. There are also other Git servers like Garrett, Roadcode, just to name a few of them. And if you don't like to run your own infrastructure, you can have Git as a service. So Git repositories and all the server stuff. There are services like GitHub or also GitLab, to name just a few of them. There are more around. So as GitHub is one Git as a service provider, this service was launched back in 2008. This service has free and paid plans, and they have changed over the time. It was bought in 2018 by Microsoft. Officially, Microsoft said they liked it that much and they used it that much that it was for them a nice match, a nice fit. GitHub offers more than just the Git services. It offers the authentication, user management, a nice web interface. And as it's running as a service somewhere in the cloud or on another machine, you don't have maintenance to do yourself for that, pay the electric bill, have the space requirements. But as we also learned a few weeks ago, if there are hiccups in the network, Git might be down for a short while. So we are using Git and GitHub, and it's just more than sharing your project files. You may see this. Are you still this guy that has multiple copies of its project somewhere on its desk? So you shouldn't. And Git is a good way to do that. We will do a live demonstration. That means there are maybe a few things that can go wrong, but we start with the first GitHub account, create locally a repository, commit changes to it, and then publish the repository as private. So only the main account can see it. It's not public. And then later we'll make it public. And the second step, second account or a second developer will clone the repository, modify its content, and give the modifications back. So this is the time for live demonstration. If we have any questions so far, please write them in the questions box so we can answer them as we are moving ahead. We have prepared a little setup. Our first developer is running a Linux machine, and he is using the GitHub desktop tool. The GitHub desktop tool is officially supported for Windows and Mac, and there is an unofficial port to Linux or Ubuntu in this case as well. For this project, we have prepared, finally crafted.
Yes. I'm not sure, are the people seeing what you are seeing? I just see the slide.
Okay, sorry. Then I need to go to the AV part. Sorry for that. So should be better. Yeah, there's the question, what is a pull request? At the end, if you are not a team member, but if you are accessing a public repository and change something, you are not allowed in the first place to just write these changes to the repository you do not own. But you can say, hey, I have here made these changes and I think they are great for your project. Would you like to get them? So the maintainer of the original project can have a look at that and can add these changes to his repository back if he likes it. So that's what the pull request in short terms is, and we will demonstrate that. It's really handy if you do open source software projects, or if you have any kind of collaboration with with developers outside your own team. So the first thing to show is we have here not a source code project, but a KiCad project. We have finally crafted our versions from 1 to really final. And it's not a good way to do it. So we use the GitHub desktop client to create a new repository locally on our machine and then publish it to GitHub first as a private repository where only I, as a developer, can add changes and then make it later public. So we can fire up the GitHub desktop. The icon will be the same on your Windows or Mac machine. We create a new repository on our hard drive. It wants a repository name. We use KiCad project for this one. We add a description. And then the GitHub desktop will ask us where we will put this repository. And I've created a folder where I will put those on my local file system. I chose no git ignore, and I also choose no license, and I also don't initialize with a blank README file. I just say create repository. It will take a time. On Windows and Mac, it's working a little better. And then if we go into our file system, to the folder we just mentioned, there is a new subfolder KiCad project. And this one will be where our repository will live locally on our hard drive. So I will use the contents of my folders, my first version. And as it would be boring to see me do KiCad stuff live, at least for a GitHub webinar, we will use that way to add a few changes to our repository. So these are now the files we have created inside the repository. And in the GitHub desktop, you can see, hey, there are changes inside, and I've added new files. You can see the plus sign at this point. And you can also see the changes inside the file. So that's what Clemens showed on the web client, you can do locally. And then we add, we prepare a commit. We will say, okay, this changes we have now done. We would like to commit locally. We would make to a kind of snapshot at this point. Call it first commit. And commit it to main. This is our main branch, you can see. At this point, no data is transferred to GitHub. This is all happening locally on your machine. And suddenly you can see you have a kind of history. This was our first commit. We will do locally now a second commit. So we will change these files. Like updating a few bugs and minor tweaks that have gone wrong. At this point, we have the version 2 that has a few updates in it. So moving around. That was not the right one. Yes, replace. And as you have now, or as we now have changed files, the GitHub desktop will track which files have changed. Not all files have. You can see here, files that are just changed have this little dot in them. You can also see here locally what has changed. And can say, okay, this is second fixed. So at this point, all we have done is locally on our machine. And now we are going to go to publish the repository. That means that you can see live after we have published that. And if we made that public on GitHub, the files are just committed. So at this point, we are just locally and have done just the changes on our hard drive. Now we will say, okay, we want our material to be published. Hit the publish repository. And here's one thing, keep this code private. This was, until a few years ago, a paid option to keep your code private. This is new. Now you can have your code private and work privately on your Git repository without anybody seeing it, only the people you're allowed to. For this, I will first commit it private, and then we will change that to public over the GitHub GUI. This should take a while. While this is publishing, we can go, this is the web page from the developer or the repository page. And you now can see, if you go to github.com/virtualdev1, there won't be any repositories for you visible. I, as a logged in account, can see that. And what we now can do in the settings of this one, in the danger zone, change visibility. So we can make that public. Make that public. So this means if you now go to github/virtualdev1, written that way, you should be able to see the code in the GitHub repository. This is now live. You can change that also back later to private. And back. So that's what I can see. You will see the included project files. So this means if we sign out here, right, we can have a look at the project, and we can see now all our project files. So that's fine so far. Yes, the question is, can you simply undo an update? Yes, you can, sort of. It would be a little different than that. You can say, okay, locally, please revert changes in commit. So we can go back. And we have currently changes there, and yeah, you can do it. You can revert it, and then you will do a new commit. So whatever you do, so if you commit something, in the first place, if you commit something wrong, you mean, yes, you can change that so that the end result will be fine. There are advanced techniques even to remove a commit from a Git repository, but that's advanced stuff, and that's currently something we won't do today. So, but you can go back to an earlier stage and do a new commit. That's possible in the first place. So okay, and worst case that could happen is that some parts get really messed up. So yeah, especially with the Linux version, I get a little bit of trouble with the Kaike changes. Yeah. Usually, if you do an undo, I mean, the Git is mentioned to keep track of all changes you did, and also of an undo, if you would like to say. So the idea is not, yeah, just to remove a commit, but to make it right and then commit it again, that you don't lose the history. That's the idea behind that stuff. So changes, push to origin. So we now push that to GitHub. It means every commit you do here, that's done locally. And if you are fine with that, press the push button, and then it will be put into your external Git repository. Oh, I need to hurry up a little, I see. So back to the track. Yeah. This means all your changes you do, you will get the whole history, everything you have changed or somebody else has changed on your team. So we will use the final version. Copy that over. Wrong folder. So, and at this point, so we do not commit again to our local file system. And as said, on Windows and on Mac, the GitHub desktop client runs a lot smoother, but it works on Linux, so that's fine. And you should now see the first final release or first final commit for what we have done at this point. You can check that on GitHub. So, and not done. So the interesting thing is you can also see what has been committed. There's the commits button, then you see the history of what has been done. It's really interesting if something's going wrong. Yeah, disk space. The question is how many repositories can I use? In theory, unlimited. You're just limited by file space. So this was our first developer. He has now published his project, and now we will switch back to a second developer. We have prepared a second machine that's running Windows with the GitHub desktop on Windows. And what we now do at this point is we say, okay, the work is interesting, but we want to do a few changes to the work our first developer has done. And this is where it becomes interesting. As Clemens showed, you can download GitHub code from GitHub, and with the GitHub desktop, we are able to clone a GitHub repository fully. That's not the download zip file, but it's a little bit more. We say clone repository from the internet. Say we have a URL, then where we want to save that, and I just put it in the default space. Then it's cloning the repository from our dev1 locally to the hard drive of dev2. And what's now interesting is if you click on history, you will see everything that has been done to this repository. So you can change, you can track any changes our virtual dev1 has made, which is quite interesting if you are curious what has been optimized or what files they have touched. So what our dev2 now can do is grab the files, open them locally on his disk drive. Open project. Can also have a look at the KiCad project itself. I mean, Clemens in the chat is asking good questions, and their answers to those questions. We will come to that again later, so that everybody can participate also in that discussion. If we now say we want to make a few changes, like moving around some parts of the board, prints, stuff like that, we hit save. Our file has changed, and we say, okay, this is better than what dev1 has done. We can first say change the label. And whatever you do, it's really kind to write a small description what you have done for this commit. And also you can see there's a little exclamation mark that says you don't have write access to KiCad project. Do you want to fork it? So we have now done our change locally. So this means this here is done on the hard drive of dev2. And now if we say push origin, it will say, hey, you don't have write access to virtual dev1, but do you want to fork the project? And to fork a project means you take a certain, you do a copy from his Git repository to your GitHub account and create the same repository with the same data and history. Say, okay, we want to contribute to the parent project. Then the GitHub desktop will set things up for us. So, and we say, okay, we have done changes and we want our dev1 to be notified. So this means we need to do a pull request. This will inform dev1 that we have done changes to the project and that we would like dev1 to take over these changes into his project. For that matter, we go to our dev2, to our page and to our account, and say, hey, there's this pull request tab. And it means do a new pull request. We say, hey, this is what we like, the repository we like to add stuff to. This is where we did our changes. This is our repository. And say, hey, please create a pull request and inform dev1 that we have changed something. You can add a nice description that depends on project. And if you ask if there are separate test environments where you can test stuff like this, you can set up Git on your own machine, but there's not something like a sandbox for this stuff. You would need to set up your own small Git or Gitish environment. So we say create a pull request. That has been done. And it says, okay, that would also fit. And it's not a problem. And from now on, it's the task of our virtual dev1. So we need to change virtual machines at this point. Let our virtual dev1 take over. Sign in. Super secret password. And what we now can see on our page, and also he gets a mail notification, but this pure dev doesn't read his mails for whatever reason. There's a new pull request popping up. And suddenly you can see, hey, somebody changed something to our repository and wants us to include these changes he made. And you can click on that, what he has done. We can see the commit he has done. We can see the files he has changed and what he has changed. And with KiCad, well, source code is a lot easier, but KiCad is also fine in this case for this demo. And we can say, hey, merge pull request. We like to have that. That's a good one. confirm. Takes a second. And what's now happening in our repository, we can see that online, is that we can see, hey, there was something merged from another developer. We have a new commit. We have changed files. And if we now, with dev1, fetch our own repository, we can suddenly see in our history that our dev2 has changed parts and that it's now been included into our repository. So that's what the pull request will do. So like, hey dev, I have made changes to your work. Please take them over into a repository. I think that would be a great idea. So that's this part for the merge part. And as I can see, time is moving. We will do a small Q&A section. I hope until here you find it interesting. There's a lot more into Git that you can do, and setting up a test environment, that's also a good idea. So I will switch back. Yeah. Then we'll give back the voice to Clemens.
Mute. I think we are here now.
Yeah.
In the Q&A section. So thank you, Matthias, for this presentation. If you have any questions, like I said before, you can type them in the chat box. Let me have a look. There is nothing there. We already answered questions during the webinar. Here's one I can move over to the...
Yep, there is a question. Is there in a pull request a way to tell which changes has been made and why it should be taken over? Yes. So let's have a look back. Just will open that. Pull request. I need to see the closed one.
You have to go back to your screen.
Yeah, I'll just hop over there. So at the merge, or our virtual dev1 in the KiCad project, you will see the merge request and you'll see the files that have changed. And also you'll see every line that has changed at this point. So you can clearly tell what he has done. And with source code, it's a lot easier. With KiCad files, it's a little bit complicated. So, but you can see everything he has changed and moved around for whatever reason. So yes, you can inspect it in before, and you should expect it in before you merge something into your own repository. And you can also say, no, I don't want that. You can also decline merge requests. You have here this conversation. And in this conversation, if the one that submits the pull request doesn't explain what he has done, you can ask him, hey, please write down what you have done before you merge it. And if you don't like the answer, you can also just decline the request for this. I hope that answers the question. Is there a protocol for refusing changes if the owner doesn't like them? Could you keep multiple branches active? Yes.
We are having multiple questions now.
Okay. Sorry.
The questions we answer are on the screen.
Sorry. That's separate. I think we have answered that. I would
like to add to this one that you can just create a repository or an account and fiddle around. You keep your stuff private. Delete and update whatever you like. So there is not really a need for an special test experiment environment. You can just play around. It's all for free, so it's very easy. Then here, this one, you were on this question.
I were on this question. Yes. The first is you can give other people direct write access to your repository if you want to. Then they can do whatever they like in the bounds they have. With the pull request, you have the advantage that people don't have direct write access. So it means everything they like to change at your repository needs to be done through a pull request, and you have to approve it. And also pull requests can run against multiple branches. That's a different story. Branches is something we don't today have time for. That would be another second step webinar for GitHub usage.
Okay, another question.
Yes, I think Clemens, you can tell more about that.
Yes, that is indeed possible. If you create a release from your repository by clicking the release button, etc., and make a release, it will put in the source files, but you can edit what you the list of files that you make available, and you can also add stuff to it. So you control the release completely. Then there was here, we have a classic question. This question we get every time. And the answer every time is the same. Yes, we do. We are making a recording right now, and it will be published at our YouTube channel, Elektor TV at YouTube. And you can, I don't know when, hopefully tomorrow, maybe on Monday, and then you can watch it again. Let me see. Oh yeah, this one was answered incorrectly by me, I think. So maybe we can go into detail on this one.
Space
free in GitHub.
Ooh, I have to. That has changed over the last months, but last time we looked it up, it was, I think, maximum file size 100 megabytes per repository, something like that. But it has changed.
Okay, and number of repositories is unlimited. That used to be limited for private users or for free users.
I think they are now at unlimited.
Yeah, you should know there is also, you can also pay for GitHub. You can have a paid account, and then you have much more options. But for free use, I think the limits were set to unlimited, so that's no limit. And maybe on file size, I don't know the file size. But GitHub, of course, has lots of documentation on their website. So just look around and you can find the answers there.
Yep. So if you go to github.com/pricing, you can see what the free user will get. And currently there's 500 megabytes of package storage.
Okay.
Unlimited public and private repositories. So, yeah.
Here we have a question about a new webinar. Can we do that?
Yes. I would more say yes, Visual Studio, but I would more go for the Visual Studio Code and then also for the Platform IO stuff, the more embedded way. But yes, we could do that.
Okay, here we have something related to KiCad.
KiCad and library management is a story of its own. So if you want to share a KiCad project, you have to make sure that besides the files that are included in KiCad itself, your own creations are also be provided in that repository.
Is there maybe something here to do with the ignore file, the git ignore?
You can exclude files that are not published, that are in a Git folder, yes. But it's not like giving if your files are public, it means they are public, so everybody can access them. It's not like if you want to have an access right, you have to make it private, and then you can give certain people certain access rights to certain files on parts. But that's more the advanced topic.
Then do we think that Altium dblib library management will be beneficial using GitHub? Probably. Everything will be beneficial using GitHub. Actually, I don't know this library management. I don't work with Altium.
There is one thing to note for all Git files. If you're uploading big binary chunks, that's not the Git strings. So Git is best with plain text files or textish files like XML or whatsoever. That works best also for version tracking. If you upload real big binary blobs, yes, you can do that. It works. But let's say change management or you won't see any visible changes any longer on the web UI because the files, it's binary. It changes more than you will ever be able to display.
Yes, this is also a problem with many PCB CAD programs that save their files in text, in human readable text, but rewrite them completely after changing just a little bit. So the file is completely different, even if you changed just one tiny thing, contrary to software where usually you don't move around all the code every time you change something, you just correct a typo or add a function. So it's much easier to see where the differences are. In a binary file, this is impossible. Then is it better to use GitHub, Git desktop or Git integrated inside Eclipse or another IDE?
Yeah, I have my personal opinion about that, and I'm not sure about yours, Clemens. But for me,
I think everybody has its own personal opinion about that. So I think it's a matter of taste, what you prefer. What else? There's public questions, but not in the. No, that's okay. 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 I don't see any questions anymore.
Yep. For the Git integration, it heavily depends on the tools you use. If you have an IDE with a really good Git integration you like to use it.
Yeah, there was a question about. Let me see if I can find it again. This one. Now publish it. GitHub Desktop and Git GUI for Windows. There are all sorts of interfaces for Git, so this is also a matter of taste, of course.
Yep. Let's put it that way. If you are new to Git, the GitHub desktop is built to give you an easy entry into that world. If you are more for the command line or rough Git GUI, that's not that nice and user pleasant. That's also an option. So the Git GUI is just an addition to Git, to the Git part. It's a little rough, and the GitHub desktop is it's built for an easy entry with a lot of assistance, as you could have seen.
Okay, last one. It's 5 o'clock. Well, Matthias also looks forward to part 2.
Yeah, I mean, definitely give us some feedback what you would like to see. What would you be interested in for the next topics? I mean, we have showed a little bit and just a little bit of what Git and GitHub can do.
There is one question coming in here.
File version numbering to a file name.
Well, GitHub does this when you make a release. You have to give a number, a version number, and that number is added, appended to the name of the release. So then you get, when you download the release, you get the version number in it.
Yeah. Question is then at that point, what are you targeting for?
Yeah. Okay, let's stop here. It's 5 o'clock. We have filled 1 hour with GitHub. And there are many more hours to fill with GitHub. This is just we just scratched the surface, as they say in situations like this. Here we have some additional resources that you may want to consult. I would like to say thank you all for watching. Thank you for being with us. Matthias, thank you for co-presenting this with me.
Thanks, Tim, for the chance to do so.
Yeah, and see you next time, maybe for GitHub version 2 or for some other webinar. Okay, goodbye.